For decades, human spaceflight has relied on a massive terrestrial safety net. Thousands of engineers, flight controllers, and specialized personnel monitor every heartbeat and thruster burn from screens right here on Earth. But imagine you are 225 million kilometers away, and mid-sentence, that lifeline vanishes. The radio cuts to static. You are entirely alone in the dark. When left without instructions in a hostile void, the natural human instinct is to panic. This sudden disconnect challenges our perception of how space exploration operates, stripping away the comfort of external guidance. In reality, astronauts don't assume the mission is lost the moment the radio dies. Before they ever leave the launch pad, crews endure months of training in isolating environments to prepare for these specific events. Modern spacecraft are designed with the certainty that communication blackouts will happen. Survival depends on the immediate execution of pre-planned autonomous checklists stored right there on the ship. The first step on the emergency checklist is to remain calm and continue following the mission timeline. Initial communication loss is often expected, anticipated by mission planners long before the first engine ignition. This diagram illustrates an orbital blockage. As a spacecraft slips behind a planet, moon, or even its own structure, the radio signal to Earth is physically severed. Crews treat these interruptions as predictable orbital mechanics, managing the downtime according to a fixed schedule. The situation changes when the silence outlasts the planned blackout window, suggesting the issue might be inside the craft. The crew systematically hunts for internal hardware failures, checking for shifted antennas, testing for radio malfunctions, or debugging software errors. Every component aboard a crewed mission follows a strict rule of engineering. Never depend on a single piece of equipment. If the primary system fails, astronauts transition to secondary hardware, backup radios, independent power supplies, and redundant computers. These layers of redundancy allow the crew to broadcast blindly into the dark at scheduled intervals, trusting that the ground will eventually receive their status. In the worst-case scenario, days pass without contact. Without ground oversight, the crew independently manages critical life support, balancing oxygen, scrubbing carbon dioxide, and recycling their own water supply. This diagram shows the independent navigation suite. By utilizing star trackers and sun sensors, the spacecraft triangulates its orientation against fixed coordinates without help from Earth. This stellar data feeds into onboard computers, allowing the crew to plot contingency return trajectories on their own. Previous NASA tests have already proven that spacecraft can calculate paths and complete the complex docking process with the International Space Station without manual flying. Modern spacecraft are engineered as independent islands, built to protect their crew even when the tether to Earth is broken. Deep space missions, like the journey to Mars, make constant supervision physically impossible. As this diagram reveals, the speed of light limits communication. A signal from Mars takes between 4 and 20 minutes to reach Earth. Waiting for a reply to an emergency alert could take nearly an hour. In a life-threatening crisis, that delay is often fatal. This distance forces a total shift in mission logic. Survival depends entirely on the spacecraft's internal systems and the crew's ability to act without oversight. Deep space crews take on the full burden of specialized roles, operating simultaneously as the mission's surgeons, structural engineers, and navigation experts. In these remote reaches, silence is an expected mission parameter, factored into the design of the vehicle and the training of the crew, which leaves one final, unresolved challenge for long-duration space travel. We have engineered machines to survive being cut off from home, but we have yet to see how the human mind will cope with total, unmitigated isolation.